Hello, this is Gary Marr of Glendower Community College. This screencast is for my SAS 156 Python 1 students. In this video, I wanted to talk about class inheritance, which is the primary topic of Chapter 11. We're still in the world of object-oriented programming, where code reuse runs supreme. Now, code reuse is so important because software is basically labor-intensive. Ask each one of yourselves, how long does it take you to do these assignments, and how many times have you sat down to maybe spend a half hour only to see that half hour turn into an hour's worth of effort? Well, this has always been the case with software, and time is money. So most organizations would encourage or prefer their programmers to use object-oriented techniques, where code is developed and then shared across a number of applications. In this case, we have a class called employee, a class called production worker, and finally a class called shift worker. All of these classes, since they are things, could be used in a whole host of applications. Everything from employee ID cards to possibly an employee check to a supervisor list to a shift list. So all of these applications would then in fact instantiate one of these classes to manipulate the data that these classes own. By using one copy for multiple programs, if we have to make a change, we make it in one place. We can also be a lot more secure about the quality of our code if we're using it once in many programs. And actually we'll hit this topic in a second, but let's move down a little bit. And as you can see, we have employee. It has a constructor or init method. It has two private members, name and ID number. Remember that self is always a keyword used to identify that variable to be included in this class object called employee. It's got setters and getters so that the sets can update the data item and the getters can retrieve it. Now, let's go back to the thought I started. If I look at this second class, you'll see where it is inheriting from employee. That's why in the parentheses it says employee. If I wasn't inheriting this code, then what I would have probably had to have done is take this block of code up here and embed it somewhere inside this class. Well, if I got a little farther, you can see that I also have something called shift supervisor, which also inherits from employee. So if I didn't inherit from employee, that same block of code would have to be included in this class along with this class. Now, if for some reason anything changed in name or ID number, which is owned by my parent, I would have to make the corresponding change in this class and also in the other class. But by inheriting it, any changes in employee will automatically be picked up by these other classes. This will create fewer lines of code, fewer confusion, and if the testing is thorough enough, with enough rigor, I can pretty much be assured that these classes that I'm using will be defect-free. Obviously not without some testing, but still, I stand a much better chance of having defect code if I'm using one copy as opposed to every programmer out there in this business creating their own versions of employee, production worker, and shift supervisor. If you look at the child class, which is production worker, you'll see it still has a constructor or an init method. It's going to bring in name, ID number, shift number, and pay rate. Now, two of these data items are actually owned by my parent. And if you look at the statement below the header, you'll see that employee is called .init, which is the method that exists up in my employee, and it'll pass it the name and the ID number. This particular class will take shift number and pay rate, which doesn't exist in the employee class, move that information into the private variables it owns called shift number and pay rate, and use the corresponding setters and getters to update or return information on that data item. The same thing happens down here with shift supervisor, with the exception that it has its own two data items called salary and bonus. It also calls the employee init method to pass name, ID number. It has private variables that are identified with the self parameter because these parameters or these data items are owned by shift supervisor. If I toggle over here to the actual application, I'm going to import EMP, which has all the classes. Okay, this file up here. It's going to have some local variables in the main module. our main function. It's going to ask some information which is going to be put inside the instance of the class, much like the assignments in 10 did. Here is the instantiation of the Shift Supervisor object, and what I'm doing here is I'm saying from EMP, that file that I imported, take that Shift Supervisor class, pass it name, ID, salary, and bonus, instantiate that into a new variable called supervisor, and supervisor is the variable I will use throughout the rest of my programmer, as evidenced below. I'm going to print a line out. It's going to get the supervisor's name, get its ID number, get its salary, and get its bonus. Name and ID coming from parent code, but still being supervisor because supervisor inherited it, and then salary and bonus being unique to the supervisor class. This is about as simple as you can get with inheritance, but I think it will illustrate how inheritance supports code reuse. It should make for higher quality code that can be developed in less time. I'll let you run this on your own. This is exercise 11.2 and it's in the textbook. If you have any questions, please let me know.